welcome to my bench. Today we've got an oldie but a goodie. This is a Shure M67 professional mic mixer. These guys are ubiquitous. I can pretty much guarantee you that every radio station out there that's been in business for at least 20 years has at least one of these sitting on a shelf. Probably more than one of them still in service. These things are workhorses, and they've been around forever. Let's see, this one, don't know the exact date. 1970. That's what it says on there. Anyhow, this one, first of all, I'll show you what the meter is doing with a little bit of input on it. There we go. That's probably not good. And if we look at the output of this thing on the scope, there. That's not what I would call a decent looking signal. However, if I turn the input, or the output up actually, we start to see we've got something resembling sine wave there. Can't see the scope. There we go. Something resembling sine wave. I'm feeding it from this. Come on, focus. There we go. It's a Sound Technology 1710A Distortion Analyzer. And I cannot get this thing to measure anything close to distortion. So, let's find out what's wrong with it. Let's turn it off. Poor thing. Okay. Pulled this thing out of service today. They said that it was humming. I'll bet it was. I replaced it with a newer model of this. But, let's take this apart. Yeah. And it's all... You can tell how old it is. It's all flathead screws. Let's see. This one has a rack mount adapter on it. You don't see too many of the rack mount adapters, basically, because most of these things set by themselves. I'm not even sure that this is a professional rack mount adapter that came with it. It might just be a rack panel that's been cut to make it work. Quite possible. Whoever did it did a nice job, though. Okay, there's that off of it. And this thing will not be going back into service. It's just time to retire it. Alright, and to get these apart, down here on the bottom, we got a couple of screws. Oh, this thing says it had new capacitors in 1992. Wow. Alright, well, let's take a look at this thing first. Alright, if we look at the front, here we have these are the inputs. Now this one has 4 inputs, 3 microphones, and a mic or line input, and a master output. It also, on this one over here, it has the ability to turn on an oscillator to do a level test on the meter over here. It has low cut filters so that you can cut out low, the low rumbly parts of sound and speech or whatever for each one of the inputs. And like I said, this one is switchable between mic and line. The master is switchable between +4 and +10 output. And over here it's got a little switch for on, off, and battery check. Yeah, they ran on battery also. Whoops. On the back, we've got our 4 inputs, mic 1, 2, 3, and 4, and mic level output and line level output, which is balanced, and a headphone output, a ground, and the ability to put 30 volts DC into the thing. You've got, this is the switch over here that turns mic line 1 or mic 1 into a tone oscillator. This is a mix bus that you can put something into it and be able to mix internally at line level. Be able to mix internally with whatever you're putting into these. I don't know if it works with this one or not. I know it works with these 3. Over here, this is your mic line switch for mic 4, and this is your bridging input. If you want to bridge the input, or if you want to terminate the input to 600 ohms, or if you want to bridge it to the rest of the world out there that is 600 ohms that you're working with. In radio, pretty much everything was 600 ohms. It's not anymore. Alright, there's a little screw here in the front, which we got to get out, which is like halfway out already. Interesting. And we'll open it up. There we go. What does that say? Okay, 1974. Registration number 001, 1974. Alright, here we go. Here's what's in the little bugger. Let's get this down a little bit more here so you can see it. All of the inputs, as you can see, come into transformers. It's all transformer input. And these little transformers are exceptionally good transformers. These things, they're expensive even today. These little matching transformers, they're just great. The inputs back here, all of these XLRs, these are all pop riveted in. Everything's pop riveted in. The switches are fairly good quality. Not the greatest, but they're good. The pots are just regular pots, but they seem to hold up pretty well. They get noisy, but all pots that are open, as you can see, these are open to the world down here, so they're not sealed, which you would kind of expect, but Shure didn't do that on these. The output's transformer coupled, so it's transformer in, transformer out. And over here is the power supply. Not much. A little transformer, on-off switch, light. Couple of lights, one. Yeah, got 2 lights for the meter. That's nice. And somebody has already replaced the capacitors in here, but they did that in 1992. Anyhow, right now I want to see if I can figure out what's wrong with this, or why it's doing what it's doing. So first of all, pull you back out a little bit. Let's set up the Distortion Analyzer here and see what we can see. That's interesting. Oh, there, now it's on. Alright, so let's see. This Distortion Analyzer confuses me a little bit. I'm going to feed it -50 because I'm on the input, and set it to calibrated 0 for that, and give it total harmonic distortion with an output level. Oh, that pot's dirty. It's like, what was I saying about the pots? Look at that. Oh, that's horrible. Here's a, give you a little view of it here. Oh, okay, so I'm just turning the output pot up and down. Oh, that's nasty. But you see how it's not even symmetrical? Whoa. That's not a good look. Alright, and we'll try to set it so it's got sort of a zero level output. Input pot's not too bad. And set my level to there, and find out what my harmonic distortion is. I'm on 3%, and according to this, my total harmonic distortion at 3% is reading what? About 1.5 or 1.2%, somewhere around there. Bad. So that would explain why they said it sounded bad. I guess our best bet first is to see if any of these caps in here. I think it says that the caps were replaced, and I think they just mean the power supply caps were replaced, because those are the only ones I can see that look like they're new, and they're probably okay. But these guys down here, they're not. We do have a schematic for this. It's right here, and it's fairly good shape. First of all, you do voltages. Always do voltages. See what our voltages are here on the end of our capacitor. We got 37.9, and it says 34. That's all right, but what does it look like? Find out what the actual waveform looks like of the output of the power supply. Darn good. Virtually nothing. So if it is humming, it's not the power supply, because I've got no ripple at all on that, so that's fine. Okay, what about our other voltages here? I found out a long time ago, just check the voltages first. That'll get you halfway to what you need to do. Alright, both pilot lights are out. Okay. But the pilot lights in this are not part of the circuit. They just run completely off of their own portion of this transformer. Let's see, we got 13.4 volts on C29, which is 400. So where would you be? I don't have a parts layout in this thing. 14.14. I presume that's it. Yeah, I got 250 at 40 would be the 39, and that's the on-off battery switch. So, so the power supply is not out of line. So, let's see what these are like. See if these capacitors are any good here. I don't know if I can do this without taking it out or not. because taking this board out of here is going to be a pain. That one looks fair. That one's still got voltage on it, I think. Yeah, it's got 2 volts on it. Turn the power supply on, see if I can drain some of this off of here. Oh, got 12 volts on it. Wow, okay. Big discharge. Okay, unplugged, everybody's off. Short. The way this thing is designed here, it will bleed the caps off, so I wasn't too worried about that. Let's try this again. 7 volts on there. Where is it getting the voltage from? Yeah, there's 0.6 there. There's still 6 volts. Wow. On there. I'm completely unplugged. Interesting. Well, let's see. I don't know. This thing will absorb a little bit of the voltage if there is actually any voltage there. I mean, if it's just a surface voltage, it should be able to take it off. So let's put it on the little box. These 2 blue ones. I am going to short out this cap though. There. Okay, this says 223 microfarads at 0.25 volts or ohms. And this capacitor, whoever put it in here, put it in making sure that you couldn't read it, is 220. 220/50, so that one is fine. Even in circuit, that's fine. Try you. 500 microfarads at 0.4 ohms. I don't know where that is in the circuit, but I find it hard to believe that that little cap is 500 microfarads. IEC. Five microfarads. Really? 5 microfarads at 35 volts. And it's reading in circuit 470. That's weird. Okay. Alright, so we gotta take this out. 1, 2, whew. Okay. This is not actually meant to be worked on. Everything is just hardwired to this board. That capacitor there definitely needs to come off. Wow. I don't know. I should be able to pull that up there. But yeesh. This is fun. Oh man, these are horrible. Okay. The ends don't even go together. So, yeah, okay, no, I can't really get that board out of there without a whole lot of trouble. However, this cap is soldered to this little thing that comes right out of the board here. Just a little standoff. Got to get better pliers. These just terrible. Okay. There. It's always easier with the right tools. Always. Ah, out of the way. Thank you. Now let's test it out of circuit. See what it says. It says nothing. It says nothing. All right. So that's no longer a capacitor of any kind, I guess. Let's take this thing back over to transistor and see what it thinks is in that circuit. And it's a resistor, a 14 ohm resistor. Wow, interesting. That doesn't look like a resistor to me. And this thing went with the positive that way. Is it marked? Yep, it's marked. So that's 5 microfarads at 35 volts. Interesting. This one here, I don't know. Let's see if I can measure this one in the circuit. The fact that this was working at all means that almost everything else in it appears to be good, which doesn't surprise me. These things just are workhorses. Alright, this one says it's a capacitor, but what? Puh! 4,844 microfarads. Well, no. That can't possibly be right. Keep doing this, but let's pull it out the old-fashioned way from the top and measure it again. Ooh, you can smell that old-fashioned board. That's interesting. And out of circuit, it is 132 picofarad. I don't trust that. Let's take this thing back over to ESR check and see what it says. It's 187. What? it's bouncing all over the place. Of course, I don't know if that's bad connections or what. 1.27, 9.3, 2.5, 157, all at 0.14K. So I'd be willing to bet that that isn't any good either. And just for grins, this thing's sitting on the output here. That's the mic level output cap. 4.6 microfarads at 7.4 ohms. Okay. Well, I know we got 2 bad caps and 1 good cap. So we need that's a 4.7 out of 5 because I don't got 5s anymore. This is another 4.7 at 35. So 4.7 at 35. I don't have any axials at 35, do I? No. So we'll have to put radials in there. Just, there we go. 4.7 at 35. Give it a test. Just because we can. Yep. 4.6. And let's see. One of these is going to be fairly easy to do. The other one, not quite so much. Because it really, getting this board out of here is going to be a pain. Some of this old stuff just was not meant from the start to be worked on. Come on. There we go. This wire down here out of the way for now. We'll look these parts up later in a minute and find out where they go. Come on, get out of there. Okay. And we'll go right to there. Wrap it around this little binding post. Grip it on there. Give it a little solder. Yep. Wire back. Kind of dorked that up, taking it off, but I can get it back on there. I did. Okay. Now this one, I think what I'm going to do with that one is I'm just going to cut it off right about there so as I can get to it. This is going to be interesting. Okay. you will continue up. Give this a little bit of a tint also. Ooh, good, took it, good. Even though these are exceedingly old devices, everything in them was good for the day. Let's put it that way. I mean, exceptional for the day. This piece of equipment probably did more to put Shure on the map for radio stations than almost anything I could think of, including microphones. Now, let's see if we can get that down in there. Because they're just little workhorses. There was a whole set of these. There was this mic mixer. There was a line mixer. There was a switch box that you had that you could switch your different inputs in and out. And the whole mess ran off of 30 volts. And the switch box itself held the batteries if you needed actual batteries. So I believe it was 3 or 4 9-volt batteries. I can't remember if it was 3 or 4. And it would run for a fairly long time on those batteries. Quite well. And so you could use it when you were out doing remotes. If you didn't have power in those days, I mean, you did remotes out in the back of the local hardware store, or basketball games, and you didn't actually have the availability of decent electric or anything like that. So a lot of this stuff all ran on built-in power supplies, battery power supplies. I've done many of them. Many remotes at Schottenstein's with Billy Weber. Out and back under the tent with a 20-foot piece of pipe and a Yagi antenna on top of it for 400 megahertz get back to the station. Yeah, when we didn't have ISDN lines or anything like that, we just did stuff over RF. So I still like RF to this day. All right, well, let's see. That's back in. Basically, there aren't any more. I mean, these greenies almost never go bad. I mean, literally never go bad. These guys are okay up here. All right. So, let's plug this in. Tell you what, though. Let's just, because, let's do a little spray here. I know you can't see what I'm doing. I'm just spraying into the pots. And give them a little, yeah, that's much better. That feels better. They were kind of mushy. Very mushy. This is the stuff I use. I don't know. Everybody's got their favorite. This is my favorite's Deoxit. It's expensive, but I like it, and it works. Remember in the old days, well, some of you out there will remember in the old days, you went and got contact cleaner from Radio Shack or something like that, and you brought it home and got yourself a potentiometer or something, and one that you didn't care much about, and sprayed a tiny little bit on it to see if it would eat the plastic up and turn the thing into a frozen up glob of melted plastic. You had to use the right stuff or you ended up ruining your parts. Oh boy, those are the days. Alright, let's plug that into there. Let's plug that into there. That's plugged into there. You're off, turn you on, poof, nothing blew up. scope. Yeah. Let's take the output here of the there we go. Alright, so what do we got? We got minus. Oh. It's still doing something weird. It's still doing something weird. Okay, because it just, the needle just sort of went up and started doing something weird. Alright, so let's put it in the center here. Put on my level. Give it minus. What is that we've got coming out of there? Ah, interesting. Wow, that's interesting. It's oscillating. If we look at it here, see the needle? I don't know if you can see that or not, but that needle is just pegged. If I take that down, and I turn it up, it goes down till it gets up to a certain point, and as soon as I start getting any signal out of it, it pegs and just stays there. And what I'm getting out of on the scope is that, whatever that is. So I'll turn it down for you. Watch it go away. Still got something there. It's noise, but as I turn it up, we'll start to get some. No, we won't. Wow. There, I turned it off and turned it back on. Now it won't do it. Well, there we go. There, I'm at about 8 on the meter, on the needle. And as I bring it up, as soon as I get, that's a lot of level right there. And it ain't working. So we got some work to do. Find out why this thing is doing what it's doing. I knew it couldn't be that easy. Of course not. Let's plug this into 2. Plug you into 1. Look at the schematic here. Let's find out where we got this stuff. Alright, so let's go. You know, the mic goes into here, goes down through Q1 and Q5 and all over and out to the mix bus. So we can look at the mix bus and see if we've got that oscillation. And we do not. Matter of fact, we don't have anything. Okay. So we got Zippo on the scope. Let's turn this down. Let's turn this up so I can see something on the scope. Wow, okay. I literally don't have anything on that mix bus at all. Alright. are these things. Let's find out if I come in through my transformer. So my first one is going to be Q1. Q1, there's Q1. All right, let's turn this down because it's just beating the living, what's out of it. Minus 50. Oh, I can still see minus 50. Okay, there we go. There, and this is a, don't know what that is. It's a NPN transistor. Okay, well, no gain, and then Q2, or Q1 and then Q5 is right behind it. God, with wires all over it. Okay, so I got a fair amount of gain there, and it's pretty. Okay, so we're going to say that that's okay. Alright, so we'll come out of that, and we'll go all the way through to low-cut filter. I don't think that's going to make, no, it doesn't make any difference. Okay. We'll bring that down and we'll go into the base of Q9, which is right here, and find it first, because that's 1, 2, 3, and 4. Wish they would print the numbers underneath them. Okay, there's Q9. Emitter base. I don't know if these are emitter base collector base emitter. I have no idea what they are, but that's Q9. We'll try voltages. Okay, so Q9 is supposed to have approximately 1.5 volts on the base. There's 7 volts on that pin. There's 1.5 volts on that pin. There's 1.0 volts. Okay, good. So that's right. So these are emitter base collector. Collector's got 7 volts. Is that right? Yep, 7.2 volts. That's perfect. And that's biased, so that's not relying on the input. So let's see. Q9 base. I got, there we go. Turn it up a little bit. I got some input coming in from Q9. Not much, but I'm down minus 50 dB, so I don't expect to have too much. I mean, my input is like minus 50 dB. It's pretty small. Emitter base collector of Q5, so I got a fair amount there, and then it comes out, the low-cut filter goes through C16, which is C18. At least it's marked on the board, some of them, but they're marked underneath them. C9, C2, C23, C16. Okay, here's C16. On one end of C16, I got some. Okay. Doesn't change with low cut. On the other side of C16, I got some. Because it's going through a 33K resistor and then into the base of our Q9. Yes. And the collector of Q9 got a fair amount there. Got a good amplification. So this is how you do it, folks. There ain't no other good way. So I got that emitter. Comes off the emitter of Q9. Because Q9 is an NPN. A little bit. Yep. And a little bit. The collector. Okay, so that's a feedback loop. And then the collector goes through the master gain control and into Q11. And Q11 is right here. There's the base of Q11. Yeah, that gives me gain on the base. And then the collector. Yuck. Ow. Ooh. Alright. Let's take a look at this. Alright, so we've got... See, really hard to do when you only got two hands here. Post-production. Okay. Here's the base of Q11. Here's the collector of Q11. Oh my. And there's the meter on the front of this thing. So if we turn this down, the meter keeps doing that. It just drops, but then it comes right back up again. Okay, well, let's find out what's wrong. Voltages first. Always voltages first. So the base of Q11 is supposed to be about 0.55. 0.59. The collector should be about 13 volts. The collector's 5 volts. It was 5.7. Yeah, it's supposed to be 6 volts, it says here. Okay. Well, let's see. Going into one more test here. So the L2, there's a coil here someplace. Where's the coil? They're counting that bead around the base is the coil. So let's look at C21, C20, C23, C21. Here it is. C21, one side of it, and the other side of it. So it's not changing. And C, okay. The other side of C21 is okay. What's the emitter voltage? Have I got? Hard to get to. The emitter of that thing is 180 ohms off of ground. So it should be about 0.05. It is. Okay. 0.01. Yeah, 0.01 volts. Interesting. Well, something in our master gain here is messed up. And it's oscillating on us. Yeah. So, I don't know right off the bat if we've got a bad capacitor or a bad resistor. I mean, there are a couple of 1 meg resistors in here. Well, I'm not going to bore you with that. I'm going to start doing some resistance measurements, and I'll be back. Okay, well, welcome back. After much gnashing of teeth and crying and going, what the hell? I finally found the problem. What I had was when the master was turned all the way down to 0, like that, the output would slowly rise and then start just peg at +3 over here on this side. And on the scope, I think I showed you, I had an output of a weird looking waveform at about 3 hertz. I don't know what I did to the rest of the circuitry, but the output would just go up and it'd stay there, and then you couldn't cut it back down again by turning the level up. Well, I went through and checked every voltage, all the greenie caps, all the transistors, of course. I had to pull the board out, which is kind of difficult. And pulled out all the caps and checked them with a regular checker. And with this checker, which is fair to middling little capacitor checker. And this is a B&K Precision model 815. Nothing's fancy or wonderful, but it does an okay job. Plus, I also checked everything on my little, this thing, you know, and everything checked perfect. It checked just fine. And so finally, I was like, okay, what can it be? I mean, I went through and made sure that if somebody had recapped this thing, which evidently they did some of it, you know, did they do it right? Okay, they did it right. Everything was fine. And I finally got down to this cap here, which had been replaced. Now, according to the schematic, this capacitor right here, find something to poke with, is this capacitor right there on the schematic. It's 400 microfarads, 25 volts. Well, about a month and a half ago, I sat down and I built a capacitor tester that Mr. Carlson put up from Mr. Carlson's lab. And I decided, you know what, I'm just going to put it on there. And, you know, this thing's a big electrolytic. This is 220. It's supposed to be 400. Yeah, it's not critical in this particular circuit. It's just a coupling cap between the output of the last transistor amplifier, or the push-pull amplifier system, and the transformer. Well, I took this cap, this 220, and hooked it up to this, which is my representation of Mr. Carlson's box, which will measure very small leakage amounts on capacitors. And I hooked it up to this. Now, this is a 220 microfarad capacitor, and this thing from Mr. Carlson takes a while to check a 220 microfarad capacitor. And sure enough, this thing leaks. It tests perfect in every way. It doesn't show bad on the, you know, on the highest ohm position I've got on my Fluke 37 multimeter, or on my Sencor DVM 38 on high. It tests just fine. On both of my capacitor testers, it tests just fine, and it shows no leakage in the mega ohms range that I can get out of any of my meters until I put it on Mr. Carlson's capacitor meter, and it doesn't tell me what the leakage is, but this thing leaks. And evidently that leakage is enough for this capacitor right here. It feeds some voltage evidently back. I don't know how, but it feeds something back evidently into this meter circuit, which makes it oscillate. And you can see the oscillation all the way back to Q9. That was weird. Interesting. Other than shotgunning, which as a technician I really don't like to do because you don't know what you fixed, I would have never found that. I would have considered this capacitor to be good. So, in conclusion, Thank you, Paul, Mr. Carlson. And if you want to know how to get this, make one of these, go on Patreon and support Mr. Carlson. He that man is really smart, and I thank him very much. I got this poor old boy fixed, and now let's see what we got here. Let's turn it up. I'm feeding it an input level of about about minus 50 dB into the mic input level. And I will turn this up to about 5, right about there. And this up to 5, and get it up to 0, about 0, on the VU meter. The low cuts are out. I'm putting a VU range of +4, not +10. And according to my total harmonic distortion coming out of this thing from my Sound Technologies right now at 600 Hertz is approximately, well, I'll take a picture here and show you. See if we can see that. About 0.2 what? I'm on the 0.3 full scale, so 0.19 THD. See, I'm on the 0.3 with my input level set at 0 and total harmonic distortion of about 0.19. That is good enough for me. So we got this little guy in. I'll tell you what, let's check all of the inputs. Make sure we got, pull him up to here. Yeah, about 0.2, 0.19, 0.2. I mean, I'm not going to reset everything on there. It's sensitive enough that hands swinging around will set it off. So there's one. Yeah, oh, tight too. And then on this channel, set up to about the same thing, about 0.22, about 0.2 or 0.22. And then we'll put this on mic level, plug it in here, bring him up to about, unless this one's been converted. Yeah, this fourth one, we got to do that on line level, because some of these things were converted, and this one's been converted. So I got to do that one on line level, take it up to about -10, pull it up to here, check my level, level's perfect, and THD on my line level input on that one without any messing around, and back off a little bit, is about 0.23. So there we go. It works. It works perfectly. That was, oh yeah, there we go. Here, for this one here, take a picture and show you. There you go, about 0.21, somewhere around there, with a -10 input. So Like I said, if you want a really nice piece of equipment to get yourself out of trouble when you're checking this, some of this old stuff, some of the new stuff. This was a new cap in in 92, but yeah, it's leaking ever so slightly. Okay, well, there we go. It's fixed, ready to go on the shelf and pretty much be a shelf queen, but you know, I just like my equipment to work in case I have to grab something, and that's, you know, in an emergency you got to have something that works, and stuff sitting on the shelf that doesn't work is worthless. By the way, I wanted to show you the low-cut filter that's in these guys. Basically all it does is put a .022 right there. Puts a in and out a .022 greenie for a low-cut filter. That's all you really need, I guess. Anyhow, hey, thanks for watching. Give it a thumbs up if you like it, and don't forget to subscribe. I really love seeing the subscribers, and any comments you got, make sure you put them down there. I like answering comments. Thanks for watching.